So section 9.3 is all about right triangle trig. 90% of what you are going to see today is review from geometry and discussions of what we can use from geometry. All right. A few things are going to be added in, which means that you kind of need to know and understand a few things that are going to be added and just kind of, they weren't used in regular geometry, but they're going to be used a lot in calculus. If you remember way back to geometry, one of the things that you might have been told is you like the law of sines a lot. So lots of people like using the law of sines. But the thing that you have to remember is the law of sines didn't work for certain angles. You had to have the angle either less than 180, or if it was greater than 90 degrees, you had to really pay attention and focus on what you were doing. That topic is going to come back up from what we're going to talk about now. So a couple of those topics are things that we really have to make sure that we're paying attention to. Okay, so a few notes that I want you to kind of understand and remember or know for the future. Your book sometimes uses theta, it sometimes uses x, and it sometimes uses t when it's using variables. So these are the variables that you can kind of expect to see in your book. They are all just variables. It doesn't matter what the variables are. Just know that if I say something like sine of theta, if I say something like sine of theta, I'm saying this is the unknown angle. If I say sine of t, t is the unknown angle. If I say sine of x, x is the unknown angle. Typically what we're dealing with is theta is going to be if the rotation or whatever the angle you're using is in degrees. And typically t is if the rotation is in radians. So typically they use t for radians and theta for degrees, typically. So that's just something to kind of think about. And then this is just kind of random. Sometimes they use x, sometimes they don't. Sometimes we'll use x. It's just a matter of preference. My calculus classes in college use theta almost every time. All right. So very quick review for trig is if I ask you to solve or use something like this, your calculus. So like if I ask you to solve sine of q equals and then gave you a number like 0.1234, your calculator cannot calculate the sine of q. So calc can't do sine q. So it can't solve for q this way. So one thing I want to mention to you is you don't divide by sine. Because remember, if I'm solving for q, one of the things that people tell you at the very beginning of geometry is, oh, I'm just going to divide by sine on both sides. You can't. So what we have to do is we have to use the inverse. So this is where the inverse shows up from these functions. I hope to not have to spend too much time on this because this is a huge topic in geometry. So in order to solve this, you would do inverse sine. You would switch these two pieces right here. So you would get the inverse sine of 0.1234 equals q, and that would be able to solve q for you. All right. Now, depending on whether this is in degrees or radians or whatever it's in, your answer has to be, or your calculator has to be in the mode you're thinking. So your calculator has to be in whatever mode you're thinking in. If you're solving for degrees, your calculator has to be in degrees. If you're solving for radians, your calculator has to be in radians. So whatever mode you are thinking in, your calculator has to be thinking in. So in this case, if I asked you for the number of degrees, q would be around 7 degrees. All right, so if you solve this in your calculator, q would be about 7 degrees. All right, now a couple things that I want to mention to you and bring up because this is something that's very, very important. All right, I'm bringing up this point because this is something that we talked about in law of sines in geometry. All right, if I ask you to solve the sine of 10 degrees, and I asked you to solve the sine of 170 degrees, those are both going to give you the same answer. Because if you look at your unit circle, if you look at the numbers that are kind of in the same spot, like 30 degrees and 150 degrees, if you look at 45 degrees and 135 degrees, if you look at 60 degrees and 120 degrees, those angles give all the same sine values. So if I typed in the sine of 10 into my calculator, and I typed in the sine of 170 into my calculator, I get about the same answer, which is about 1.7 or 0.17365. Both of these will give the same exact answer. So you have to understand and know what kind of equation or what kind of question you're dealing with. So your calculator will always give you this kind of answer. You have to be able to find and understand what numbers and angles are going to be the same. Now, one thing I want to mention to you is if you look at your trig identity sheet, this actually might be one that I have to upload to you. So I have a trig identity sheet that I'm going to have to upload to you. But what you have to kind of look at is some of the sign values are going to be the same. So get this sheet out and look at this sheet while I'm looking at it as well. So get this sheet out, your unit circle, and look at kind of what's happening. Your sign values are going to be the same in certain areas. All right, so your sign values are essentially going to be the same in certain areas. And I'm going to try to describe to you why that works. Because if you look at your unit circle, and if I have my X and Y axis, if you look at your unit circle and you look at 10 degrees, like let's say that's 10 degrees, your Y value is going to be up a certain amount, right? It's going to be up a certain amount, whatever that amount is going to be. There is going to be another location on this circle that is that exact same height, and it's going to be over here. So these are both 10 degrees off of the x-axis, and it raises us a certain height. So this would be 10 degrees off of the x-axis, but that would be 170 degrees. Because these two are both the same height away from the x-axis, which means if they're the same height away from the x-axis, they're going to have the same y value. Since sine is talking about the y value, it should be the exact same number. Whatever this coordinate is, they should be the exact same. The x's are obviously going to be different because one's going in the positive direction and one's going in the negative direction. But if you look at this, the y's should be identical to each other. So these are the same types of angles. They're called reference angles because they are the same distance away from the x-axis. This one is 10 degrees away from the x-axis. This one is 10 degrees away from the x-axis. So what you have to know is if I give you a sine value and ask you to solve for that sine value, you're going to have to know what sine value I'm looking for. So for instance, I could ask you the sine of 170, and it doesn't matter. The sine of 170 is 0.17365. If I ask you or say something along the lines of this, find the largest angle with, find the largest angle between 0 degrees and 180 degrees. Actually, let's say 360, because it could work with 360 as well. So find the largest angle between 0 and 360 degrees. This just means on the unit circle, one rotation. It's find the largest angle with one rotation with a sine of 0.4321. So this is saying we have an unknown angle. And that unknown angle has a sine value of 0.4321. So this is saying that I have a sine value of some angle of it, which equals 0.4321. This is asking for the largest angle. Your calculator is only going to give you one angle. You have to understand that there are multiple sine values, multiple cosine values, multiple values that are going to produce the same exact answer. Okay? So sine of 0.4321, if I type that into my calculator, I'm going to do the inverse sine of 0.4321. And in this one, it gives us the degrees right here. It says degrees here and degrees here, which means that my answer should be in degrees, so my calculator should be in degrees. Okay? So I'm going to go to my calculator, and I'm going to show you what I would do in my calculator. All right? And in this case, we're going to round a little bit. So we're going to round to whatever is the closest. So I'm going to make sure my calculator is thinking in degrees. So I'm going to go down to degrees and select that. And then I want to find the inverse sine of 0.4321. And I'm going to hit the enter button. And this tells me that my angle is about 25.6 degrees. Okay, so my angle is about 25.6 degrees. So I know when I'm looking at this, theta is going to be 25.6 degrees. Now that is an answer, but is that the largest angle between 0 and 360 that has a sine of 0.4321? So what I'm asking you is, if I look at my unit circle, if I look at a unit circle like this, and then I have my axes like this, if I look at 0.2561, or I'm sorry, 25.6, I don't know where I got that. If I look at 25.6, I can clearly see that I would have a sine value of 25.6 going this way, and this would give me my positive 0.4321. That is one of the areas where I am going to have the 0.4321 as the sine value. If I go the opposite direction like this is still 25.6 away, and it is going to have the same exact height as the other one does. That height and that height are the same. So there is another angle that will produce the exact same sine value. That angle is going to be all the way to here. So the easiest way to find that sine value is to take 180 minus 25.6, which is going to give me, I can't do that in my head.
154.
Thank you. So that's telling me that my other angle that's going to have the exact same sine value is going to be 154.4. So my other angle is going to be 154.4. If you want to double check that, all you would have to do is go to your calculator and type in sine of 154.4 and then hit the equals button. And if it equals 0.4321, which it does, then I've found the correct angle. All right. Now, some things you have to think about, because you might be thinking, well, why do we know it's not down here? Why do we know it's not down here? Well, if I open up my angle this way, the y value is down below the x-axis, which means the y value would be negative. This can't be negative because it's not. It can't be down here because it can't be negative. So you just have to use your understanding of the x's and the y's when you relate them to sine and cosine. If you use the x's and the y's and relate them to sine and cosine, you know if it's positive, it has to be up here for sine. If it's negative, it has to be down here for sine. If it's negative for cosine, it has to be over here. If it's positive for cosine, it has to be over here, because x's go to the right and x's go to the left. So you have to think sine means y value, so y is positive is up, y is negative is down. X's and cosine go together, so x's go to the right means positive, x's go to the left means negative. So you have to be able to think of that. This is one of the things that is different between geometry and calculus. You have to know and understand whether it's asking you for a bigger answer or a smaller answer, all right? So for instance, I could ask you, or I could give you the same set of directions. I'll give you time to answer this one to see if you can figure it out. But I could give you the same type of question. So find the largest angle between 0 and 180 and 360 with a cosine of negative 0.325. So try this one. And you want to find the largest angle with this. So the largest angle with a cosine of negative 0.325. I'll give you a shot on that, and then I'll try to explain it again. But think, cosine means x's. This value has to be an x value, so think about it that way. All right? So I have an inverse cosine value of negative 0.325, and that's going to tell me what this angle is up here. Remember, this angle down here has the exact same x coordinate. It's the exact same x coordinate. So this will have the same exact cosine. So I have to go to my calculator. And once I go to my calculator, I can find very easily what the inverse cosine is of negative 0.325, which is about 109 degrees. We'll call it 109 for ease. So this is about 109 degrees. So this tells me that my one angle is 109 degrees. That means that this angle right here is 109 degrees. Now, a couple easy ways to think about this, because these are in the same location. If you want to, all you really have to do is figure out the distance between here and here, and then make that distance the same between here and here. So the distance, and this is a bad rendition of the drawing, I guess, but this distance right here, if this takes up 109 degrees, and this gets me to 180, this right here should be 81, which means that gap should be 81. So this gap is 81, so this gap is 81. So my next angle should be 180 plus 81, which takes me to 261. So cosine of 261 should give me negative 0.325. So that tells me that my angle, if I continue on, of 261 should give me the same thing. So if I hit cosine of 261, it should give me, oops, am I in the right mode? What did I do? What did I do, people?
Shouldn't it be 71?
Huh?
Is it actually 81?
Is it 71? Oh, it's 71. Thanks.
Yeah.
That was almost catastrophic. My mental math was very poor here. So it should be 71. That means that some people are getting it. That's good. So let's correct here. This distance from here to here should be 71 degrees, which means that this distance from here to here should be 71 degrees. So if I want to figure out what my cosine is, I should take 180 plus 71, which is 251. So that means that if I go to my calculator and type in cosine of 251, that should give me my negative 0.325, which I have right here. Obviously, the rounding is a little tiny bit different. That's because we rounded this angle to begin with. All right, so we rounded the angle to begin with, which means that the rounding here is different, but you can obviously see it's close enough to move on from there. All right, so that being said, this is how you work with these things. Sine and cosine, you just have to be able to come up with your idea of what the circle looks like and where the x values are the same. Now, this is an important thing because you have to be able to play around with what cosine values are and what angles are. A lot of people get the angles confused with the values. The values are on the outside of your unit circle. The angles are on the inside of your unit circle. So when it tells you it has a cosine value of something, it's talking about the number on the outside of the circle. When it tells you it has an angle of something, like theta equals or x equals or something like that, that's on the inside of the circle, okay? So what I'm gonna do right now, I'm gonna kind of just run through real quick what SOHCAHTOA are so that we remember what SOHCAHTOA are. And then I'm gonna just kind of define real quick what angle of elevation is, what angle of depression is, all right? So I want you to remember those two things so that we can have those, and then tomorrow we can start out talking about any right triangle trig type questions that you have, all right? So first things first, if I look at a right triangle, which you might have to use what we just talked about, okay? So that's why we went through that whole thing. Oops, wow, that's a great one. So you might have to use what we just talked about in these types of questions, so I just wanted to make sure that we did talk about those, all right? So I'm gonna make a right triangle. So I've got a right triangle right here, and obviously we can choose any of these angles to be theta or x or whatever you want to call it, but I'm going to call this angle theta for our intents and purposes. We know that the angle or the side across from that is always labeled as the opposite. The longest side is always labeled as the hypotenuse, and the side touching the angle is the adjacent side. We know we have SOHCAHTOA. All of these are on your trig sheets as well, with sine, cosine, tangent, you know what they are. So those are all on your trig sheets if you need them as well. But the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of theta is equal to the opposite over the adjacent. Now you could then go through and figure out what the reciprocals are for cosecant, secant, and cotangent. So cosecant of that angle is going to be the hypotenuse over the opposite. The secant of the angle is going to be the hypotenuse over the adjacent, and then the cotangent of the angle is going to be adjacent over opposite. So those are just the reciprocals. Those are things that you should be able to know and understand as we work our way through. So those are just things from trig that you're from geometry that you need to remember. This is just SOHCAHTOA. I had a couple people in my geometry class a couple years ago where I wrote SOHCAHTOA. I told them the whole story about SOHCAHTOA. went through the whole spiel with SOHCAHTOA. And then after like 6 weeks of me saying SOHCAHTOA and writing this all over the place, they're like, did you realize that the S could stand for sine, the O could stand for opposite, and the H could stand for hypotenuse? And then they're like, wait, the same thing happens. The C stands for cosine, the A stands for adjacent, and the H stands for hypotenuse. They thought that I made up the whole, they didn't understand why I told the whole story of SOHCAHTOA. So the entire time people were like, wait a second, that stands for what this is. It's so easy to remember now. So if you never knew that, that exists. That's the whole reason why SOHCAHTOA exists, is so that you can remember these. All right. So real quick, angle of elevation. These go along with word problems. So this would be something along the lines of a 5 foot tall person is standing 10 feet away from a tree with an angle of elevation of, actually we would say something like a 5 foot tall person is standing a certain distance away from a tree. We don't know what that distance is, right? And then they're saying that the angle of elevation is 30 degrees to the top of the tree. We would create an equation, and the angle of elevation would go from their eye level to the tree, and then it would go up to the top of the tree, and then we would create our right triangle that looks like this, and we would fill in the information that we have here. So we would know that the angle of elevation is how far they're looking up. So if I said the angle of elevation was 30 degrees, this angle right here would be 30 degrees. If it tells me that the person is 5 feet tall, and maybe we would have to know. So maybe this person is standing 10 feet away from the tree, like this. And then the question might be, how tall is the tree? So the things that you would have to do is you would then have to solve for this value right here, and then add the 5 feet of the person from their eye level to the top of the tree. All right. So that would be something that you have to solve and add. And this is something that you should be able to do. So right now you see that you have a value here, you have an X value here, and you have a value here. So I would know that I'm using the opposite and the adjacent. So I would say, since it's the opposite and adjacent, it's the tangent of 30 degrees is equal to the opposite over the adjacent. And then I would solve for X. So I would obviously do 10 times the tangent of 30 equals my X value. Again, make sure your calculator is thinking in degrees if you're thinking in degrees. So 10 times the tangent of 30, which is 5.8. So I would know that X equals 5.8. And if I want to know how tall the entire tree is, I would just take 5.8 plus 5. So my entire tree would be 10.8 feet tall. All right, that's angle of elevation. Remember, angle of depression works the exact same way, except for angle of depression is giving you this angle up here. Oops, that's not what I wanted. Angle of depression is giving you this angle right here. But it is the exact same. These two angles, angle of elevation and angle of depression, are congruent to each other. Those two angles are congruent. So if they give you the angle of depression, you can use the angle of depression to also find the angle of elevation. They're the exact same. These two lines would end up being parallel to each other. So you can see that these two angles should be the exact same. All right. So I'm going to leave you with that. I'm going to call the recording good.